Model accuracy drops from 95% to 75% due to stale features. The architecture design flaw? Missing data validation. The trick to production ML is robust pipelines. I'll show you how to build them. Wait till you see the data validation step.
A naive approach ingests data directly into the feature store. This breaks because data quality issues propagate downstream, causing model drift. What happens when the data is corrupted? Data ingestion from various sources lands directly into the feature store, bypassing any validation checks. The absence of validation causes inaccurate features to be used for training and inference.
A robust pipeline starts with data validation. Think about it. Why is data validation so crucial? We add a validation layer using great expectations because it ensures data quality before feature engineering. This prevents bad data from poisoning the model. The validation layer checks for schema compliance, data types, and value ranges, ensuring that only clean data proceeds to the next stage.
Next, we implement a feature engineering pipeline with Tekton because it provides real-time feature computation and storage. This pipeline transforms raw data into features suitable for model training and inference. Can you see why this pipeline can scale? The pipeline consists of feature extraction, transformation, and aggregation steps, ensuring that features are consistent and fresh.
Now that we've implemented a data validation pipeline, we need a robust way to store these features. A key architectural decision is choosing between an online or offline feature store. What happens when this cache fails?
An offline feature store, like a data lake on AWS S3 or Google Cloud Storage, computes features in batch. This is because it's cost-effective and ideal for features that don't require real-time freshness, like user demographics. Think about it. Why would a single database break at this scale? An online feature store like Tekton or Feast serves features with millisecond latency. This is the bottleneck. Can you see it? These are critical for models requiring up-to-the-second data, like fraud detection or personalized recommendations. This works because these features are pre-computed and stored in a low-latency cache. The feature serving layer sits between the feature store and the model inference service. It's responsible for retrieving features and formatting them for the model. Remember that cap theorem trade-off? It matters right here. A Redis cache with a TTL of 1 minute ensures low latency while balancing consistency and availability. Now that we've covered the feature serving layer, let's explore feature validation. Feature validation ensures data quality and prevents unexpected issues. Without proper validation, bad data can corrupt models, leading to inaccurate predictions and poor performance. Imagine a fraud detection system where suddenly the feature transaction amount becomes negative. What happens then? The model might flag legitimate transactions as fraudulent, causing customer frustration and lost revenue. This is why feature validation is critical. That brings us to schema evolution. Data schemas often change over time. New fields are added, existing fields are modified, or even removed. And if the feature engineering pipeline isn't updated accordingly, it can lead to data inconsistencies and model drift. For example, if a new customer location field is added to the data source, but the feature engineering pipeline doesn't extract and transform this field, the model won't be able to use it for predictions. This is why it's important to have a robust schema evolution strategy in place. What happens when a new feature is introduced?
Effective monitoring and alerting are crucial for maintaining data pipeline health. We need to track key metrics like data quality scores, schema version mismatches, and feature drift. Without proper monitoring, issues can go unnoticed for extended periods, leading to significant data degradation and model accuracy loss. Think about it. Why would knowing about the data quality matter so much? If the data quality score drops below a certain threshold, an alert should be triggered, notifying the data engineering team to investigate. For more on monitoring, watch our video on ML monitoring.
Feature pipelines automate the process of feature engineering, ensuring consistency and reliability. By defining a clear and repeatable process, we can minimize errors and improve data quality. A well-designed feature pipeline should be modular, allowing for easy modification and extension. This also allows for testing of different pipelines for A/B testing models. What happens when a feature pipeline fails? A/B testing is the way to ensure features are performant prior to a full deployment. For more on A/B testing, watch our video on A/B testing.
If you found this helpful, please like, share, and subscribe for more technical deep dives like this.